let's look at string concatenation problems. Here we can see a couple of examples of the bad use of string concatenation. The addition operator should never be used for string concatenation, period. The problem is, if you're not familiar with the way that strings work, is that strings are immutable in C#. Now, the compiler is going to do some things to make this a bit more efficient, but in the broad picture, in the perfect world, this is actually going to produce a number of strings. This and is together are going to produce one string. So there you have three already. This plus is, which results in this is, plus the a, and then the resulting is going to be this is a. So that's a fifth string. And then the last string there is a sixth one, and then you put them all together and you get 7. And that 7th string is assigned to S. And the garbage collector at some point has to clean all those up. Now, as the C# compiler has gotten better at optimization, if it finds something as obvious as this, it's going to optimize this bad coding out for you. But you shouldn't rely on it, because it can't always detect that this is what's happening, especially when you're doing things like you see in the second example. And that is, this is being determined at runtime, this v value, so that this probably won't be optimized out. So the solution is to use the functions directly on the string object itself. So if we refactor this, this would be string.concatenate or concat, and then just supply each of these. And this is a function that's going to do a high performance concatenation of all the strings. There aren't going to be additional strings created. It's an internal piece of code that can do this very efficiently. It's pretty much as readable as the addition operators as well, so you're not going to get a big difference in what you're building. Just remember to use the concat function on the string object. For the second string, the problem we have is that we have a value here, and we're calling toString, and what we really should be doing here is using the format function on string. And what the format function on string allows us to do is create placeholders. So let's bring this back to, this is a value, and we're going to use curly braces inside the string to tell it which of the parameters after this string are going to be inserted into the string. So in this case, we can just say v. Now notice I don't no longer have to say v to string, because it knows that whatever objects are being passed, and this is a params value, so you can have any number of these, to insert it into this 0 value. And in fact, we can include formatting here by telling it what kind of format to use. In this case, I'm telling it to format it as a decimal number. This gives us the ability to not worry about the actual conversion to string. This call to string would still work, but we want to avoid all this ugly code of calling it to string. We want to let format do as much of the actual formatting for us. When you're doing localization, this can become more important because these values are numbered by how they are sent into the format, not the order they are in the format. And so that if the nature of the string in localization changes the, let's say, the verb or noun order, it will still continue to do the right thing. It may be that 1 comes before 0. Now, these two methods of doing simple concatenation are really common. You're going to see it used all over the place. But there's a third type, and that's where you're trying to build up a much larger string. And this third type of string concatenation is the one I see most often in code bases, because they are correctly using format, they're correctly using concat, but they haven't figured out how to actually do this for large amounts of strings. So let me give you an example of this. If we have a string that you're building up, and you might want to add to it some more text and even more. I see this pretty commonly as well, sometimes with formatting in it and sometimes without formatting in it. A couple of solutions here. First, if it really is just contextual data like this, you don't actually need to use concatenation for individual lines, and this isn't going to give us individual lines. What you could do is use the @ quote, and this will recognize and allow you to use special characters like embedded quotes and slashes and those sorts of things. But very interestingly, it will also recognize carriage return line feeds. So if I start this by saying this is the start, hello world, hi there, this is actually going to take these carriage returns and use them in that y variable as well. So in this case, the y will include a line break here and a line break here. But most often what you're going to want to do is actually use something called the string builder. The string builder is a class inside of the system.text namespace. And the builder allows us to build up a larger string. We can say append, and this would be essentially like adding a single piece of string. This is the start. We can do append format as well. This will allow us to, much like string.format, give it a format string, and append line, which will take whatever you're going to append and then make sure there's a carriage return after it. If you do it without any text, it will force a carriage return at the end of whatever you're formatting. So it gives you the ability to do either line-based or just concatenation of different strings together. And once you're done, this isn't a string. This is where you actually would call toString, and the builder would return the resulting string. So it would only build this string once. So if you're building up any large amount of text, if you're walking through some for loop or those sorts of things to build up text, String Builder without a doubt is the way to do that efficiently. It's one of the things I suggest in almost every code review I do, because this comes up in almost every code base I've looked at. Let's see what the next one is.